Hi guys, welcome back to Kotta channel. In this video, we are going to develop a machine learning model to predict the medical insurance premium for the customers based upon their inputs. Let's imagine you have got a client who runs a medical insurance company. Due to online policy issues, insurance companies receive lots of inquiries and applications about the insurance premium. To make this process easy, efficient and quick, you have been told to develop a machine learning model to predict the insurance premium based upon the certain inputs from the user. Let's see the demo first. Here is the final web application. Medical insurance premium indicator looks like. So this machine learning model takes the couple of inputs from the customers as an features. So based upon these features, this machine learning model is going to predict the what would be the insurance premium that customer has to pay for the insurance company. Okay. So the first one is the gender, whether that particular customer is a male or female, and the next one is whether that particular customer is a smoker or non-smoker, and the next one is the region that he or she belongs to, and the age of the customer, and the body mass index of the customer, and the number of children this particular customer is having. Okay, when I click on predict, it is going to predict the insurance premium that this customer has to pay. And if I increase the age, and the insurance premium is also getting increased, because for the based upon the age our health deteriorates, right? So that is how this insurance premium is considering that age is also one of the input feature. Okay, and if I increase the body mass index, so that means that particular customer is overweight, so then it is going to predict the insurance premium will be a little bit higher than the people who are having the normal weight. So this is how this machine learning model works. Let's decode the machine learning model. Step 1, we need the data set of the users information like age, dependency, gender, whether that particular customer is a smoker or not, the factors which are going to influence the insurance premium of that particular customer. So once we have this data set is ready, then we need to understand this data set, how this data set is going to influence the insurance premium, and what kind of data we are dealing with, and what kind of information it is having, how many categorical fields are there, how many numerical fields are there, how that particular data has been distributed. All this thing comes under the data analysis and understanding of this data. So once the steps are completed, the next step is we are going to split this data set into two parts. First one is to be called as a training data set, another one will be called as a test data set. Usually 80% of the data will go to the train data set, and rest of the 20% of the data set will go to the test data set. So once we are dealing with the data set, the next step is we are going to create a machine learning model. The model which we are going to create for this tutorial is random forest. A random forest is a meta estimator that fits a number of classifying decision trees on various subsamples of the dataset and uses the averaging to improve the predictive accuracy and controls the overfitting of the model. So once our random forest regression machine learning model is ready, we will be training the model with the training dataset. And then the next step is we are going to predict the values of the test dataset by using the model. And finally, we will be evaluating this model by comparing the predictive value versus original values. So once we are satisfied with the evaluation of the model, then we are going to deploy it as a web application, as you guys have seen in the earlier part of the video. Now let's dive into the coding. Now let's install the Python libraries which are required for this tutorial. Okay, I'm just opening the command prompt, and here you can type pip install numpy pandas and matplotlib for the to draw the charts, and cbon to draw the distribution charts, and we need the scikit-learn and pickle to save the model, and finally we need the streamlit to deploy this machine learning model as a web application. So we would need all these Python libraries. If you press enter, all these libraries will be installed in your system. I'm not going to install them because I've already installed all these libraries in my system. Okay. Now our Jupyter lab is up and running. Let's create a Python notebook, and I'm going to name it as insurance premium, medical insurance premium, medical insurance predicting model. Okay. The step 1 is importing the necessary libraries. Importing necessary libraries. Okay. Import numpy as short form as np, and import pandas as pd, again short form. Next import matplotlib.pyplot as plot, and again import shebon as sns. Next import sklearn dot model selection, and here instead of from import I have to make it as from sklearn dot model selection import train test split. Next from sklearn dot ensemble import random forest regressor. Okay, so these are the Python libraries which we would need for this tutorial. Okay, now once we have imported them, now we have the data set called the insurance.csv, okay, which is in the csv file format. We have to convert it into a pandas data frame. Okay, and what we are going to do is we already have this pandas as pd, right? Now what I'm going to do is I'm going to create the insurance and scope insurance data. Okay, let's call it as insurance data pd dot read csv, and this file name, okay, insurance.csv. so what exactly happens is it is going to read the data whatever there in the csv file insurance.csv, and it will convert into a pandas data frame. Pandas data frame is nothing but a structured data in a table format. Okay, I'll show you that. Okay, now we have imported this insurance.csv file data into a insurance underscore data table. Okay, let's call it as a pandas data frame or table, both are looks similar. Okay, now let's print the first few rows, okay, from the data set insurance.head. If I use the head insurance premium insurance data dot head, it will give you the top 5 rows. Okay, here is the top 5 rows, and here we have column called age, the customer age, and the next one is sex. It defines the particular gender of the customer, whether it is he's a female or she. Okay, next one is bmi. Bmi is nothing but a body mass index. Okay, and the next one is children's, how many number of children that particular customer is having. Okay, and the next column is smoker, so whether that particular customer is a smoker or a non-smoker, and the region that particular customer belongs to a region, southwest or southeast, northwest or northeast. Okay, and finally the charges are the insurance premium. Okay, so this is the column that we are going to predict based upon these 6 columns, 1 2 3 4 5 6, yeah, based upon the age and sex, bmi, children, smoker and region. Based upon these input columns we are going to predict the final column, which is the output column as charges. Okay, now we have the data insurance.header. We have seen the columns. Now let's see what are the different types of these columns. Okay, what is the data type for these columns? Okay, insurance underscore data dot info. If I click on press enter, it will give you the information about each and every column. So the first column is age. Okay, it is an integer column, and the next sex is an object is nothing but a categorical column or character based column. Okay, sex is a female or male, right? So that's what it is, object column. Next one is bmi, body mass index. It is a numeric column, floating column. Okay, next children, number of children that customer is having. It is also an integer column. And the next one is smoker, whether that particular customer is a smoker or non-smoker. It is a categorical column. And next final one is region. Region is also a categorical column, whether it is a southwest, southeast or northeast. Okay, and finally the charges output column, which is a floating column, which is like a numerical column. Okay, now we have seen the data about each and data type of the each column. Now let's see describe this data. Insurance data dot describe. What exactly this describe does? So this describe what exactly it does is it will give you the data about the numeric columns. Okay, we have total 7 columns. Out of the 7 columns, 1 2 3, only for 4 columns this numerical data is printing the data. If you see here count, we are having the 1338 is the number of rows. Okay, let me print this one, insurance data dot shape. Okay, it will give us the information about the number of data points that we have. We have 1338 data points. That means we have the 1338 rows, number of rows are having the data. Okay, we are having the 1338 rows of the data, insurance data, with the 7 columns. Okay, And out of those 7 columns, 1, 2, 3, 4 columns are 4 out of the 7 columns are the numerical columns. Okay, and all these columns are having the data 1338, and next one is meaning. Mean in the sense the average of this column, average value for this column. The average age is 38 39 years, and average body mass index is 30.6, and average children is 1.09, and charges, average charges is 113k around. Okay, and next one is the standard deviation, and the next one is the minimum value of that particular column, and the next one is, it is not a percentage, it is a percentile column. Okay, what exactly it says is that for the age, 25% of the records are having less than 27 age. Okay, that is what the percentile gives us, and similar to the 50 percentile and 75 percentile. And finally here is the maximum value. Okay, maximum value is 64 is the age, and body mass index is 53, and maximum insurance premium is 63,770k. Okay, which is very highest. Okay, maybe it might be for 64, I think, this oldest customer, I guess. And the number of children is having is 5 children. Okay, okay, this is what it is. Now let's see if there are any, let's see if there are any null values are there in the data points. Okay, insurance data dot is null dot sum. Okay, is null dot summation. Okay, so age is 0, 60, BMI. Okay, all these columns are having no non-null values. Okay, so that we are good. Our data set is completely clean and good. Now let's see how this data has been distributed. Okay, let's see how the data distribution is happening by checking the numerical columns. Okay, let's check for the data distribution. Data distribution for numerical column which is age. Okay, sns.set. Okay, plot dot figure of. Okay, we are going to figure, and figure size is nothing but the length and width. Okay, 6,6, let's give. Okay, we can change these values, no problem. So we have this Shibon set, and then plot dot figure. Now sns dot distributed plot. Okay, this plot, and insurance data of, for which column? Age column. Okay, and plot dot show. Okay, press enter. If you see here, here is the graphical representation of that particular column values. If you see here, the age of the column 20 is more when compared to the other ages, and this data of the age column had been distributed from the age 20 to 64. Okay, that is the maximum value, right? So that is how this data has been distributed for the age column, and we could see the maximum number of records with the age number 20. Okay, and we can see that what is the count as well. Okay, insurance data of age column. Okay, age dot value counts. Okay, if you see that for the 18 is having 69 rows, and for 1968. Okay, where is for 20 is for 29. So age 18 and 19 is having more number of entries in this data set. Remaining all are 20, 25. So that is the reason we could say high spike in the age column here. Okay, so the main reason to draw this distributed plots is we'll get to know, we cannot check it each and every time, right? When you are having a large number of details, if you see here, from the age has been distributed from the starting age is 18 and maximum age is 64. So we cannot scroll back, scroll up and scroll down, right, like this one. And it is very difficult to get the pulse of the data by just looking at the numbers. Okay, but if you draw these charts, we'll get to know in a graphical representation and a single glance. Okay, age number 18, 19, 20 has been distributed one-sided, more number of records, and remaining are equally distributed, more or less. Okay, now let's do for the similar for the other column as well. Okay, age, next is BMI, body mass index. Okay, if you see here, even the body mass index is like, it is like a pyramid. Okay, and it is started around 10, let's say 10 or 10, 8 or 9, then it has been distributed maximum at row number 30. The maximum body mass index has been reached at 30, 30, 32, and then it has been reduced to till 40, till 50 as well. And there are few after more than 50 as well. Maybe those people are overweighted. Okay, And next thing is we got for age, and this age right now it has to be changed to BMI. And what is the other one? Numerical column children. Okay, final column is children, so number of children's. Don't think it doesn't make any sense to draw the charts for the distributed, but yeah, more or less number one is having more, and 2 3 4 5 children's. Okay, now let's draw the now we are done with the drawing the distributed charts for the numerical fields. And how about the categorical fields like smoker and region, and what is the other one? Gender, sex, female or male. Okay, for that one, instead of drawing the data distribution charts, we have to draw the count plots. Okay, I'll show you. Let me copy paste this code, and here instead of column charts for categorical column. Okay, categorical column which is gender or sex. Here sex, and here we have to do is x is equals to insurance data of BMI, and data is equals to insurance data. A small change. Okay, now let's try it. Instead of SNS we have to draw count plot. Body mass index, sorry, instead of BMI it should be sex. If you see here, male and female, I think more or less similar count only, just a small difference. Let's check it out, those counts as well. Insurance data of sex. Okay, dot value counts. It gives us the different types of so what exactly it gives us is, it gives us the unique values along with the counts of that particular thing. Okay, we have male and female two values, and male is having 676 and female is having 662. Just 8 plus 6, 14 records difference. Okay, the next one is what we have to draw is categorical column. Sex is done. Smoker. Okay, smoker. Yeah, if you see here, the data points for the where the smoker is more than 200, but for no it is almost more than 1000. Okay, to be frank, it is evenly distributed, but that is fine. This column is one of the columns, right? Not a big deal. And the next one is region. And we have 4 regions: southwest, southeast, northwest, northeast. Okay, and I think only southeast is having little bit of higher numbers when compared to the southwest, northwest and northeast. Okay, let's check the unique values for these ones as well. Insurance data of what is this? Region, right? Region dot value counts. Okay, oh god, let's change it. Okay, yeah, 364 it is. Southeast is having just little bit of more than 25 to 34 records extra when compared to the other ones. Okay, so I could say that when we see all these charts except this smoker column, I think all the values are evenly distributed. Looks good, fine. I think we are good with the data distribution and data analysis. And now let's print the data one more time. So here is the data, final glance. Age, so age is similarly numerical columns, so we don't have to do anything. So the next thumb rule is, when we are before feeding it to the model, once we have the data set is ready and once we understand the data, okay, as we have done so far, the next step is, if there are any, we have to check, are there any categorical columns are there or not. If there are any categorical columns are available in the particular data set, our job is to convert them into the numerical columns, because our models, whatever the machine learning models, right, those models will work efficiently on the numerical data when compared to the categorical data or character based data. So now next our job is to convert these sex categorical column and smoker column and region columns to the numerical fields. How we are going to convert that? So we already know that sex column is having only two values. One is female and another one is male. So we are going to replace that with the relevant numerical values like female as 0 and male as 1. And similarly for smoker, no as 0 and yes as 1. And regions like southwest 1, southeast 1, 2, 3, 4. Similar to, okay, southwest, east, northwest and northeast is there, right? We can replace them with 1, 2, 3, 4. Okay, let's do that. Okay. Converting categorical columns into numerical columns. Okay, now let's replace for insurance data of insurance data dot replace of, okay, what is the column name? Sex column we are going to replace. So what are the values is there? Female is there, female with a 0 and male as 1. Okay, going to replace. Need to add another round bracket here. So once we have done, then we have to apply this in place is equals to 2. So what exactly we are doing here is we are replacing the insurance data with the replace function. For which column? For the sex column. With what values? Wherever it is female, we are going to replace it with a 0, and wherever it is a male value, we are going to replace it with the 1. And the next step is in place is equals to 2. What exactly it does in place is it will be applying this operation, replace operation in the data set itself directly. Okay, that's what it is doing. Let's copy paste it for the other columns. And what are the other columns? Smoker column. Okay, and yes or no. If it is no, then we are going to make it as 0. If it is yes, we are going to make it as 1. And the next one is region. Here southeast, southwest. Okay, with 0, 1. Then again northeast with 2 and northwest as 3. Yeah, should work. So what we are doing is we are going to replace the region value columns. Wherever it is southeast, we are going to replace it with a 0, and southwest with 1, and northeast with 2, and northwest with 3. Okay, let me execute this one. It's done. Now let's print the data set. Oh, sorry, insurance data. I don't know why I'm typing data instead of insurance data. Yeah, if you see here, age has been replaced with the zeros and ones, and smoker has been replaced with the ones and zeros, and region has been replaced with 0, 1, 2, 3. Okay, now our data is ready. Now next step is we are going to split this data set into input data set and output data set. Input data set is a data set should contain the input features that are going to affect the output feature. Okay, here the input features are age, sex, BMI, children, in smoker and region. These are the input data set, and charges is the output data set. Now let's do that splitting. Okay, input data is equals to insurance data dot accept the sales column, right? Drop columns is equals to what is the column name? Sales charges. Sorry, charges. Okay, and what is the output data set? Here output data set is insurance data of dot drop. Sorry, no, only charges column. Okay, that is going to be the output column. Input data and output data. Okay, now let's print this data sets. Here is the input data set with the only 6 columns. Okay, age, sex, BMI, children, smoker and region. Now for the output data, we have only one column, which is charges column. Okay, input data, output data. The next step is we are going to split this data set into 2 parts, as we discussed earlier. First one is the training data set. 80% of the data goes to the training data set, and 20% of the data goes to the test data set. Okay, we have inbuilt functionalities already there in sklearn, scikit-learn, which we have already imported it in the first step, train, test, split. Okay, Now input training data, comma, input test data, comma, output training data and output test data. Okay, train test split, you have to pass the input data and output data, and test size is equals to 0.2. Okay, so what exactly we are doing here is we are converting this input data into two parts: input training data and input test data. Similarly, output data we are converting into output training data and output test data. Test size is equals to 0.2 means 20% of the data goes to the test data set and 80% goes to the training data set. Okay, now let's print the shapes of these ones. Okay, print input data, input training data and input test data. Okay, let's print the shapes of these data sets. Okay, dot shape. If you see here, total 1338 data points are there in the input data set out of 1070. Okay, 1070 out of 1338 goes to the training data set and 268 out of 1338 goes to the test data set. This is for the input. Similarly for the output as well. Okay, instead of input, let's change it to output. Okay, let me copy paste. I'm being lazy here. Okay, output and output. Okay, so here also 1070 same count and 268 same count. Now we are done with the splitting of the data set. Okay, the next thing is we are going to create the model. So the model which we are going to create model is random forest regressor. Okay, which I have imported here. Okay, let's create the model. Next step is model creation. Okay, model is equals to random forest regressor and estimators is equals to 100 and maximum depth is equals to 7. So what exactly it happens is n estimators, that means number of estimators is equals to 100 in the sense subtrees that it is has to create is 100 subtrees, and maximum depth is 7 in the sense it is like a level wise 1 2 3 4 5 6 7, right? So maximum depth we are giving it as a 7. Okay, now we have created a model is created. Now training the model. Okay, model dot fit of input training data, comma, output training data. Okay, our model has been created with maximum depth of 7. Okay, could see this data. So now next thing is predicting the values with test data set. Okay, and how we are going to predict is test data predictions. Okay, how we are going to predict the values is model dot predict of by passing the input test data. So here are the predictions for the total 268, right? So for those 268, here are the predictions. So what we are doing is here we have created a random forest regression model with the number of estimators is equals to 100 and maximum depth is 7. Next, we are training the model with the training data set of the input by passing the input training data set and output training data set. Once our model is fit, that means it has been trained, it is ready to predict the values which we have predicted for the test data set. Now let's see the evaluate our model. Evaluating the model from sklearn dot metrics import r2 square. It is one of the metrics that is going to evaluate our model score. Okay, r2 score of what we have to do is we have to pass these predicted values, okay, test data predictions with the actual values. What are the actual values here? Output test data. Okay, output test data is containing the actual values, right? Here we have given the input test data, which is the input data set, and output test data will be having the actual values. Output test data. Actually, this R2 score ranges between 0 and 1. If it is near to the 1, that means our model is performing very well, and if it is near to the 0, it is not performing the well. But it is usually not the case. It will come around 60-70%. I think that should work. Okay, okay, here it is coming as 0.80. That means 80%, okay, of the data is matching whatever that model has been predicted with the actual values. Okay, when comparing with the actual values, I'm completely satisfied with the R2 score of 80%. So now let's predict the new values, completely new values. Suppose if I want to predict new values like fresh. Okay, what I'm going to do is input data is equals to like first thing is age, right? 23 age. And what are the columns we have? Age, sex. Let me copy this. Home. Okay, first column is age and next column is sex in the sense male or female. Let's make it as a male one, and BMI is 35. Okay, and number of children is 2, and if it is a smoker or not, yes, he is a smoker, and reason is like southeast. I'm going with that. Okay, this is the input data set. Now what we are going to do is we have to convert it into a numpy array. Okay, input data underscore array is equals to input data array of input data, sorry, input dot as array with the input data. Okay, we are converting it. Now we have to convert this input data array into shape, reshape. We have to do that. Okay, input data array dot reshape of 1 comma minus 1. Okay, the reason why we are going to do the reshaping is, the first thing is we are taking this input data and we are making it as an array. And why we are reshaping is our model has been expecting, it is being trained on this like this, right? Huge number of records. Where is it? Where did it go? Shape. Yeah, it has been trained on the 1070 data entries, and it has been predicting the values recently 268. So the model is expecting this many number of rows of data. So but we are only expecting, we are only giving the only one value to that model, right? So that's the reason we are reshaping the model here. Okay, reshaping the input data here. Okay, now model dot predict of input data as array. Okay, it has been predicted and predicted, let's call it as insurance premium. Okay, and this insurance premium is going to be the value. So 36,143 USD dollars that is being charged with a person who is having age of 23, is a male person who is having at the age of 23 with a body mass index of 35, and he's having 2 children, but and he's a smoker. Let's change, if he is not a smoker, what would be the price? Okay, oh, it has been reduced drastically to 4370. Okay, that's really cool. Let me remove the change the children to 1. 4314. Okay, it is somewhat better. Okay, it is calculating properly. And let's increase the age to 64. Oh, it has been increased. So anyways, age and smoker, all these are the one of the major important features to play major role in predicting the insurance premium, even in real time as well, right? So our model is predicting properly. Now we are done with the model creation. The next step is we have to create a app. Okay, web-based application, right? Usually these things will happen in the web-based applications, right? The reason why I'm going to do all the web applications whenever I'm doing any machine learning tutorial videos is, the reason is I want to give you the real-time experience. Okay, if you do a machine learning development normally, until unless if you see it in a real-time usage of it by in the forms, by using the web application, then only you will be able to understand what exactly we are doing and how this model is able to help, or how this model is able to reduce the work, and how this machine learning model works in the real time, you'll able to understand all these things. So that's the reason in every tutorial of mine, I'll try to create the web application of the machine learning model which I'm creating. Okay, now we are done with the model creation. Now the next step is we are going to create a web application. So before going to create the web application, we have to save this model, right? Okay, I'm going to save this model. For this one, we need the pickle, this Python library. It will be saving the model. Okay, pickle dot dump, and the model name, model, here is the model, open, and medical insurance premium machine learning model. Okay, dot pickle, saving it, comma, with right binary access. Okay, if you see here, it has created the medical insurance premium machine learning model. Okay, what exactly we are doing is, it is the model, this whatever this model which we have created here, right? This model, it is creating a pickle file out of it. Okay, this pickle file with the right binary access, that's what it is done. Now to create the web application by using the Streamlit, I would take this tutorial to the Visual Studio. Okay, I have opened this folder, medical insurance premium, where all the Python notebook and our data set and where our model has been created, right? So I have opened that folder in Visual Studio, and here I'm going to create a new file called app.py. Okay, where we are going to create a web application. Okay, now I'm going to import the necessary libraries. Okay, and let me copy paste from here. Okay, we can copy this a couple of code from here and there. Okay, importing necessary libraries. We need the numpy, we need pandas, we don't need these charts here, so I'm removing them, and we don't need these two as well, and we'll just take pickle. Okay, now next, what else we need? Think we are good. And next we have to import the model. Okay, model, pickle dot open, here is the file, copy with the read binary access. Okay, should be good. And here one more Python library we would need is Streamlit. Okay, which is the main Python library to run this whole application as a web application. Okay, and now we are done with st dot header. I'm just setting this medical insurance premium predictor. Okay, here what I'm doing is, I've just imported the necessary Python libraries, and here I'm reading the model from the web folder which we have created earlier. I have set the header as medical insurance premium indicator, and I'm saving it. I'm just running it now. Okay, when we are running it, it is saying that module pickle has no attribute open, and pickle dot load, and inside open. I think this should work. Let me close it, another one, saving it, and run the code now. Sorry, let me close this one. Dedicated terminal. Now no warnings. So if you are not getting no warnings, to run this, okay, Streamlit as a web application, what we have to do is Streamlit run app.py. This is the command. Okay, Streamlit run app.py, the file name app.py. Okay, a caps here, app.py. If you press enter, in your default browser a window will pop up. Okay, here is the web application, medical insurance, with the header medical insurance premium indicator. Here you can go to the settings here, run and save. Every time when you're writing a code, and if you save that app.py file, it will automatically get refreshed. Okay, that's what I'm doing here. Now let's coming back to the Visual Studio, and we don't need that for now. st.header, and next, what is the thing, we have to take the input data, right? So what are the inputs that we would need? We would need the age, sex, BMI, children, smoker, and region. Okay, age, age is equals to st dot slider We are going to create a slider. Enter age. Okay, ranging between 5 to 80 years. Okay, saving it, and again I'm coming back here, and again, so if you see here, it is automatically refreshed. If you see here, we have created a slider with a starting value of 5 to 80. Okay, the user can just select his age. Okay, just like this. Okay, now the next thing is age. Next one is BMI as well. Okay, BMI. Enter BMI, body mass index of the from 5 to 100. Okay, that is the maximum number. I don't think it would require, but let's change it. Okay, let's keep it 100 only. Okay, and yeah, if you see here, BMI also, body mass index of the customer. And next one is age, BMI, gender. We would need the gender is equals to st dot select box of choose the gender. Okay, here we need the values female and male. Okay, saving it, coming here, if you see here, choose the gender, male or female. Okay, I think it would be better if the gender is in the first place. Okay, it looks good, I guess. Yeah, yeah, now it is fine. First the gender, then all these details. Next, what is it? Gender is BMI, whether that particular customer is a smoker or not. Smoker. Okay, st dot select box of are you a smoker? Smoker. Okay, with the values of yes and no. Okay, and yeah, are you a smoker? Yes and no. Okay, and next values age, gender, BMI, smoker, and then next one is the region. Region is equals to st dot select box of choose region. The region values are southeast, southwest, and northeast and northwest. Northwest. Okay, saving it. You see here, choose region southeast, southwest, northeast, northwest. Let me change a little bit. Camel case. Okay, it looks good. So when you are creating a web application, even the appearance also matters, right? Okay, and yeah, southeast, southwest, northeast, northwest. Okay, should be good now. Yeah, is BMI, and there is should be one more column. What is it? Children, number of children. Children. st dot slider choose number of children's. Okay, children's range from 0 to 5. Okay, yeah. Okay, let's put all these drop downs in the first. Okay, and sliders in second place. Okay, yeah, now we are good. Medical insurance premium indicator, and female, gender or male, smoker, yes or no, southeast region, southwest, and all that stuff, age, BMI, and number of children. Okay, so once all these details are there, so once if a user select these details, and it will automatically get stored in this particular variable. Okay, that is the advantage of the Streamlit. It will make easy for us. If you want to write for this select box, you have to write like HTML, JavaScript, all that stuff of code, right? But Streamlit gives us just in one single line. Okay, it does all the hard work for us. That's the reason I love Streamlit. Next we have the variables. Now we have to create the input data is equals to all these column values. Before going to these column values, again the next challenging part, smoker is a categorical column, we are taking it as a drop down, and region and and these two values, and even the gender as well, we have to convert them to the numerical values again. Okay, gender, if gender equals to um, female, okay, then gender value will become 0, else gender equals to 1. Okay, changing it here. Okay, similarly I'm just copy pasting. Similarly I'm changing the drop down values for what is the next column, smoker. If this particular smoker is yes, sorry, no, then it will be 0, otherwise 1. Okay, and next one is region. Region, we may have to write a couple of lines of code. Okay, if it is southeast, if it is southeast 0, right? Let me just check it out to make sure that we are giving proper inputs to the model. Southeast 0, east west, northeast northwest. Okay, 0, and if it is southwest, then the value will become 1, and northeast will become 2, if not then 3. Okay, saving it. Okay, now let's take the input data. Input data is equals to we have to pass the values in the same sequence, right? How the model expects: age, sex. Okay, age, sex, in place of sex we have used the gender. Okay, gender, and BMI children. Okay, BMI children, and what else, smoker and region, smoker and region. Okay, 1 2 3 4 5 6. Okay, total 6 columns. Now changing it to input data array. Okay, np dot as array of input data. Okay, now again input data is equals to input data dot reshape of 1 comma minus 1. Okay, now predictions, we have to do the prediction, right? Insurance premium predicted premium is equals to, okay, model dot predict the values of this input data. Okay, now you have to write that mark display string, let me call it as a display string, is equals to insurance premium will be plus string of this predicted premium of 0 plus USD dollars. Okay, now st dot markdown of this display string. Okay, what exactly I'm doing is I'm taking all these input data sets from this input term when we are giving this, selecting that input form. Okay, and we are converting it as an array, and we are reshaping it, and we are predicting the value. Okay, finally I'm creating a new variable called display string, which once all these values are selected, we have to display the final premium amount, right? So insurance premium will be, so whatever the value which will coming from the model with the underscore plus USD dollars. st.markdown is we are going to display that particular string. Okay, now I'm just going back here, refreshing it. 37333.47. I think we are getting a lot of value. Let me restrict it to only 2 decimals with the cents. Okay, um, round of 2. Okay. Okay. Finally, this is what a web application looks like. If you see here, it is directly printing the values. Okay. We have to create one button here. If st dot button of predict, okay, then only this operation should work. Now should be good. Yeah. Here is the final web application. Medical insurance premium indicator looks like. So this machine learning model takes the couple of inputs from the customers as an features. So based upon these features, this machine learning model is going to predict the what would be the insurance premium that customer has to pay for the insurance company. Okay. So the first one is the gender, whether that particular customer is a male or female, and the next one is whether that particular customer is a smoker or non-smoker, and the next one is the region that he or she belongs to, and the age of the customer, and the body mass index of the customer, and the number of children this particular customer is having. Okay, when I click on predict, it is going to predict the insurance premium that this customer has to pay. And if I increase the age, and the insurance premium is also getting increased, because for the based upon the age our health deteriorates, right? So that is how this insurance premium is considering that age is also one of the input feature. Okay, and if I increase the body mass index, so that means that particular customer is overweight, so then it is going to predict the insurance premium will be a little bit higher than the people who are having the normal weight. So this is how this machine learning model works. We are done with the medical insurance premium predictor machine learning model. If you like the content in this video, please do like and subscribe to our channel.